Welcome back, everyone. So this video is going to walk us through the two different types or two different ways to write formulas of a compound. So we're going to start by talking about the empirical formula, and then we'll move into the molecular formula next. So the empirical formula is essentially just a simple ratio of elements. So like, for example, carbon dioxide, there's one carbon, two oxygens, okay? And then we know that in this case, right, the molecular formula is the same as the empirical formula. It has one carbon and two oxygens also. But then if we start looking at some of these other examples, like let's take this one, we can see that the molecular formula over here on the right, this is the actual number of elements in the formula. So this compound has 2 nitrogens and 4 oxygens. But we see that the empirical formula looks a little bit different. Essentially, the empirical formula is just a simplified version. So if you think about your math class, right, 2 over 4, 2 to 4, you're always going to simplify that, right, to 1 over 2, right? Because both of those numbers are divisible by 2. And that's what we have here. We have 1 nitrogen and 2 oxygens. So our empirical formula is just a simplified version of our actual formula. So let's look at a few practice problems here. Okay, so we have our definition. Our empirical formula just means the simplest ratio. Okay, so let's look at a few of these examples. So for the first one, we have our molecular formula, the actual formula, and I want to write the empirical formula. So I just want to simplify. So think, okay, what are 4 and 10? How can I reduce that? What are they both divisible by? And I can actually divide, right, both of those numbers by 2. When I do that, I get C2H5. So that is my empirical formula. Okay. For the second one, I have 8 and 19. Those two numbers don't have any common denominator. So this is, I'll just put a little smiley face, that is the empirical formula, right? So sometimes, just like in the case of the CO2 from the previous slide, your molecular formula is the same as your empirical formula, okay? And again, we have the same case in the next example. This one is already simplified, so there's nothing else, nothing else to divide by. Take a minute now and see if you can simplify or write the empirical formula for the next two examples in your notes. All right, so let's check our answers and see if we got it correct. So for the next example, I have 4, 2, and 2. Those are all divisible, right, by 2. And then the last example, 6 and 6, those can both be reduced down to 1 and 1. So we just have CH. So we just talked about percent composition, right, where you calculated the percent of each element in a compound. We can actually find the empirical formula by using that percent composition as well. So sometimes we're not given the molecular formula. We don't know the actual formula, but we know how much of everything we have. So like you might be told you have 25% of one element and 75% of another element. So we can try to figure out the formula using that information. Okay, so luckily there's a little poem that can help us. We say percent to mass, mass to mole, divide by small, multiply until whole. So I'm going to show you how to use that in the next practice problem. So it's asking me to find the empirical formula, okay, and I'm starting out with these different percentages of these elements. Okay, so remember, anytime we're doing any type of calculation, our first step is to always just write down what we're given. So I'm just going to write down these 3 different values that I am given. Okay, my first step tells me to go from percent to mass. So this step is fairly simple. I'm just going to change my color here. So all we're going to do is actually cancel out that percent sign, and we're just going to put grams because we measure mass in grams. Okay, so I'm going to put little grams right above the mass. So now we have mass of each of our elements. So we're just kind of pretending like we're starting with 100 grams. So I've just changed my percent to grams. Okay, nothing fancy. Next step, we're going to go from mass to mole. So remember, if we think about our mole map, and I thought I changed the color. There we go. Just kind of keep our colors going here. So 1 mole, right? We know that we can actually find grams by looking at the periodic table and getting the molar mass. Okay, so in order to go from mass to mole, I'm going to put a little PT here, right? Because we're going to look at the periodic table. So I'm going to set up my train tracks, and I know that since I have grams on the top, I'm going to put grams on the bottom. And my periodic table tells me that there's 12.01 grams of carbon in 1 mole. Okay, I'm going to do the same thing for all of these. So again, I look at my periodic table, 1.01 grams for hydrogen in 1 mole. And then for oxygen, I have 16 grams in 1 mole. So now I could just take my calculator, right? And I know that I'm always going to divide by what's on the bottom. So once I type those things in, I end up with 4.34, 13.01, and 2.17. I usually just round to 2 decimal places here, 2 or 3. You don't want to round too much because it'll mess up your calculations. So you'll see I usually keep like 2 decimal places in most of these problems, just because that's what it is on the periodic table. So I just keep 2 decimal places throughout. Sig figs is not super important for these, but you don't want to round a lot because it'll mess up your answer. Okay, so we've done our mass to mole. So our next step, let's see, we'll do green. Okay, we're just going to divide by small. So what we mean really is by the small number. Okay, so which one of these numbers is the smallest? That would be our 2.17. So I'm going to divide every single one of these by the 2.17. Okay, so I know that this is just 1. And then I have this round, this is 5.995, which is basically 6. And then this one comes out exactly 2. Okay, so what you're going to notice, right, our next step, it tells us that we're going to multiply till whole. So we see that most of these are already whole, right? And then this 5.999, I mean, that's basically a whole number, right? That's 6. If something that isn't whole would be like 2.5, right? That like exactly half. But these are pretty much all whole. So luckily, we don't even have to do this step in this problem. Most of the time, you aren't going to have to do that step. Okay, so we have our these numbers here. Those numbers just tell me how many of each atom I have. So I have 2 carbons, 6 hydrogens, and 1 oxygen. This is my empirical formula, okay? So these numbers are just a count. They tell me how many I have, okay? And then remember, if we did percent composition, if you were counting the percent composition or calculating it, remember we have to take into account how much we have of each thing. So that's all we're doing. We're really just working backwards, okay? Whereas we're taking our percent and finding the formula. Let's look at a second problem. So I'm going to start, right, percent to mass, right, which just means, first, I'm getting ahead of myself. We're going to start by just writing down what we have. 33.88%, this is copper. 14.94% nitrogen, and 51.18% oxygen. So now we can go to our percent to mass. Okay, so remember, this is where all we're going to do is just change that percent to grams. Then we can use our mass to mole. So remember, that's our periodic table, right? So we're just going to set up our train tracks. And I'm going to look at my periodic table to get our molar mass of copper, which is close to that. So that's 1 mole. Our molar mass of nitrogen. And again, our molar mass of oxygen. And then when I just type everything into my calculator, so I'm done with that step, mass to mole. Now my next step, remember, is to divide by small. So remember, we're just going to divide by the smallest number. So which one of these is the smallest? That would be this number right here. I think I got my extra 0 added in there accidentally. Okay, so now I can just divide. I know that this one is just 1. This comes out to 2.01. So again, remember, this is essentially a whole number. And this comes out to, the last one is 6.01, again, which is a whole number of 6, right? Because we're just looking, we know we're done if they're all whole numbers, okay? So it's okay if they're, 0.999 or 0.001, something like that, right? So now all we have to do is write our formula, right? So we say, okay, copper, there's just 1, so we don't have to write an invisible 1. Nitrogen, there's 2. Oxygen, there's 6, right? Because we're just using these whole numbers there that tell us how many of everything we have. Okay. So let's look at the next problem. It's start by writing down. This is a random letter there. Okay, so we've written down what we were given. So now I'm going to let you take a chance. Go through your steps, percent to mass, mass to moles. So remember, I'll go ahead and put your little tips there. Okay, and then we're just going to do the same steps. Here, I'll color code them so they're the same as the previous, so you can kind of follow along, right? So see if you can get the answer, and then you can watch the video and see how you did. Okay, so I'm going to go ahead and fill this in. So I changed to grams. Now I'm ready to convert mass to mole. So I know that I have to look at my periodic table and get my mass of magnesium. My mass of nitrogen. And then I can divide. Again, I'm just keeping those 2 decimal places just so my numbers work out nicely. Sometimes they don't work out as great if you round too much. So if you weren't getting nice numbers, that might have been, what was wrong. So now we're just going to divide by the small, which is this one, 1.98, 1.98. And that is just 1. Okay, so this one, we'll kind of see if you figured out the trick here, okay? And it's okay if you didn't. If you got to this point, right, then I would consider that a success. This one is actually one where we have to use this multiply until whole section, right? Because 1.5, that's not a whole number, right? That's pretty smack dab right in the middle, okay? So we can't write a formula, right, that looks like this, 1.5 to nitrogen, right? We've never seen these little numbers in there, okay? So what we have to do is figure out what can we multiply both of these numbers by in order to get a whole number, right? Most of the time, it's just going to be 2. So if I multiply this number by 2, right, I get 3. If I multiply the top number by 2, I also have to multiply the bottom number by 2, so I get 2. Okay, so now both of these numbers are whole. So that means I'm going to have 3 magnesium and 2 nitrogen. So this is my actual empirical formula.